Well, hello, geometry friends. We are here today to learn how to find missing angles of a right triangle using trig functions. And remember, trig is short for trigonometry. Trig functions is sine, cosine, tangent. Okay, so that's what we're talking about doing. We've already learned how to find the missing sides. This kind of starts out exactly the same way. And what I mean by that is we use the definitions of the ratios to set up an equation. And we'll do that the exact same way we did when we were looking for the missing sides. The difference is what happens. So let's look at this one. Example 1. Okay, so we're not given the angle measures. If we were given even one of these two, the two acute angles in the right triangle, remember we could find the other one by just by subtracting from 90, right? But we're not to find the missing angle measure. So this is like I'm going to go ahead and call it theta. No, I'm not. I'm going to leave it, just let's go with A. Let's call it measure of angle A. So first thing I have to do is figure out what sides I'm working with. Here's the right angle, the hypotenuse. That makes this the adjacent. This would be the opposite. But I don't need this one at all. I'm not working with it at all. So I'm just using the opposite, the adjacent and the hypotenuse. Equation that looks just like this, except has the stuff that I know filled in. Now, I don't know the angle. So when I say cosine of my angle, I'm just going to go ahead and call it angle A. So cosine of A equals the adjacent, which is 20, over the hypotenuse, which is 32. Okay? So now here's where what's different happens, is what's next. Okay? In the past, if we were missing a side length, we would cross multiply and then solve for the missing side. Okay? If we were missing a side length, we would cross multiply here and solve for the missing side. Cross multiplying is not going to help me here. The goal is to get this angle part alone. But remember, anytime we're talking about cosine of an angle, sine of an angle, tangent of an angle, those two go together. You can't, it's not like you could divide cosine out of both sides, because that's not cosine times A, and cosine by itself is not a thing. It's not a number. So you can't divide both sides by cosine. So you can do what we call the inverse of the trig function. So remember, the inverse is kind of like the reverse. So let's talk about that. Side note, let's say we have sine of some angle equals 0.56. Okay? The inverse sine is like saying I want to undo the sine. So the way inverse sine works is I can take the inverse sine, and that's the notation for inverse sine, of both sides, and what will happen is it cancels this, and then theta is by itself. So over here, I need to do inverse sine of 0.56. This is something that I only do when I'm trying to find the angle. It's like I'm told what the answer is for the sine of that angle, and I need to figure out what angle gave me that answer. So then I go to my calculator, and if you look above sine and above cosine and above tangent, there you see inverse sine, inverse cosine, and inverse tan. So I'll press the second button to get up there. So I'll do second. First I need to turn it on, that would help. Second sine gives me the inverse sine. It's not really the sine to the -1 power, because that wouldn't mean anything, because what is the sine by itself? It's just a notation thing. When you see that -1, that's a notation thing that means the inverse. So the inverse sine of 0.56. So in other words, I'm asking what angle would give me this sine. And the answer is an angle of 34 degrees would give me a sine of 0.56. And I could work it out going forward and show that. So let's say 34.056 to try and make it a little more accurate. And I get 0.56. So it's like we're undoing the sine. Okay? It's like you give me the sine of the angle, and I'm saying I can figure out which angle gave you that sine. So we got, what, 34? And very often when we're finding angles, we go ahead and go to the nearest degree. So I'm just going to say that's 34 degrees. Okay? So if you see a problem like this, and there are some in your homework, well, if you're in my class right now, that look like that, where it's like something like this. And you're asked to find A. All you have to do is do the inverse sine, inverse in this case, cosine to both sides. Really, this over here is me showing you why it works, how it works. But you don't have to do anything with that, really. You just have to know you're going to do inverse cosine of 0.72. Another way of thinking of it is it's almost like the cosine has to get away from the A, so we move it over here, but moving it across the equals makes it an inverse cosine. It's another way of looking at it. So in this case, my angle A would be inverse cosine of 0.72, which is 43.94 degrees, so about 44 degrees. Now, the most important thing about this is to recognize that it's something we only do inverse when we're looking for a missing angle. That's the only time you use the inverse functions, okay, with the little -1. Only when you're looking for a missing angle. What tends to happen is once students learn how to do the inverse ones, they want to use it on everything. Don't use it on everything. If you're looking for missing sides, you just use regular sine, cosine, and tangent. It's only when you're looking for a missing angle, like we were here. Okay? So actually, that was not our problem. So like we are here. So let's get rid of that. So this is where we are once we set up our equation. We're trying to find the missing angle because that's what A is. So I'm going to say, okay, then A is equal to the inverse cosine of that fraction. You could have changed it to a decimal first, but I prefer to do everything in the calculator at the same time. So I'm going to do inverse cosine. It just helps me not have to round early. 20 over 32. Whoops. There we go. So this is what I typed in. And it should give me my angle. Angle A is about 51.3 degrees, so about 51 degrees. So what this means is if you took the cosine of 51 degrees, you'd get about 20 over 32. And since it's rounded, it wouldn't be exactly, but it'd be close. So that's how we find missing angles. Let's do another one. First thing you have to do is figure out which sides you're working with, and therefore which trig function to use. Okay, so this is the angle I'm working with. One of the sides of this angle is the hypotenuse. The other is the adjacent, which means that 5 must be the opposite. So the sides I'm working with are the opposite and the hypotenuse. And the trig function that deals with opposite and hypotenuse is the sine. So I'm going to set up a sine equation. All right, so here's my sine equation. Sine of x equals opposite over hypotenuse. And what that means is that x can be found by doing the inverse sine of those numbers in a fraction of 5/12. So that's what goes into my calculator. Once you get used to doing this, it's actually a little faster than finding missing side lengths. Okay, so inverse sine is second sine. Then I've got 5/12, the fraction. And I could have changed it to a decimal first if I wanted to. But I get about 24.6, so about 25 degrees. So x is about 25 degrees. Really, x is about 25 because it has the degree symbol up here already. Any questions on that one? All right, let's do another one. Example 3. Find theta. Okay, so again, we always start the same way, which is trying to figure out which sides we're working with. So here's the hypotenuse. So this is the adjacent. There's the opposite. So the two sides I'm working with here are the what? Opposite and adjacent, right? So which function do I need to use? Which one deals with opposite and adjacent? Tan. Tan is opposite and adjacent. I can't find my little reference sheet. There we go. So right here. So that's the equation I'm going to write. I'm going to write a tangent equation. Tan of my angle equals opposite over adjacent. So to get the theta by itself, that means I'm doing inverse tan to both sides. And again, you could show it if you want. In other words, this is inverse tan, so that's going to cancel. Inverse tan. So it's just theta equals inverse tan of 12/20ths, and that's when I put it in my calculator. Always get your variable alone before you try to put it in the calculator. So inverse tan 12/20. Let's do it a different way here. I could change this to a decimal first. It's 0.6 and just do inverse tan of 0.6. A lot of times you'll see a decimal there. Get the same thing either way. So this is about 31 degrees. Any questions on that one before we go on? Okay, next up, find the measure of the indicated angle. And those of you in my class, this is like it looks like in your packet on a certain page. So I wanted to do one like this. So we could call that angle x if we want to. We could call it theta if we want to. I think I'll go with theta. Right, first I have to figure out which sides I'm working with though. That's really the first thing always with right triangle trig. Here's the hypotenuse. Here's the adjacent. Here is the opposite. So opposite and hypotenuse is what I'm working with, which means it's the sine is right. So sine of, I'm going to call it x, equals opposite over hypotenuse, which means that x is equal to the inverse sine of the opposite over hypotenuse. So inverse sine 19/27 gives me 44.7 or about 45 degrees. Questions there? Okay, what I want to do is go ahead and do a couple of application problems with you. This is the majority of what you need to know from today is how to find the missing angles. But sometimes we see that in application problems. So let me find you a couple of good ones to do. Okay, so I want to do a couple of word problems because we see a lot of these. So the first one here says find the angle of elevation if you are standing 400 feet away and the building is 850 feet tall. Angle of elevation, there's a little drawing up here. And we're going to talk about this a little bit more on a different day in a different video. Angle of elevation basically means I'm standing at the bottom of the triangle and looking up. Okay, so the angle between ground level and my line of sight is what it's really called, looking up. You don't really have to know that in this problem though because they already marked it for you. It says find the angle of elevation and there it is marked for you. That's the angle of elevation. So we're finding x. So first thing we have to decide is which sides are given. Here's the hypotenuse and adjacent. Here's the hypotenuse. Here's the adjacent. So this is the opposite. So which function do I need to use? Tangent. Good. I will tell you a lot of application problems use tangent. because it makes a lot more sense for me to want to know the distance along the ground or the distance up and down, or that I would know those, as opposed to knowing the distance in midair. So a lot of times you use opposite and adjacent. Not always, but a lot of times. So to set up my equation, I'll say tan of x equals opposite, which is 850, over adjacent, which is 400. Okay, I'm finding the missing angle, so I'm going to do the inverse. Always make sure you're only doing inverse for missing angles. But this is what we're asked for, is the angle of elevation here. So that's what I'm going to do in my calculator. So inverse tan of 850 divided by 400, which you can put it in like this. You don't have to do it as a fraction. Gives me 64.79, so about 65 degrees. So my angle of elevation is about 65 degrees. Okay, next problem. Go ahead and let's look at this one. From the top of a tower, and it's not saying the same tower we already did. From the top of a tower, just any general tower, the angle of depression to a stake on the ground is 60 degrees. The top of the tower is 80 feet above ground. How far is the stake from the foot of the tower? So this is just kind of hard to unpack. We got to think about this one. Let me adjust. There we go. From the top of a tower. Okay, so I have a tower. The angle of depression to a stake on the ground is 60 degrees. They're saying I'm standing up here on the top of my tower. I'm looking down, and there's a stake on the ground. Not like, meat, but like a piece of wood hammered into the ground. I mean, who knows? Maybe there is a stake on the ground. There's a ribeye on the ground. Okay? When they say the angle of depression, and again, it kind of shows you in this picture what angle of depression is. Angle of depression means the angle between the horizontal and my line of sight. So this is the angle of depression. But let me just point something out. Depression. And this is what we always use when we're talking about angle of depression, or almost always. If this is horizontal and the ground is horizontal, then these two angles right here are alternate interior angles. So if I know that this is 60 degrees, I can put it inside the triangle right down here. The angle of depression and the angle of elevation, because this is like the angle of elevation. This is like the person looking up versus the horizontal, and this is the person looking down versus the horizontal. They're the same because they're alternate interior angles. So you can use that to know where to put it in the triangle. Okay? So here is my triangle, my right triangle. From the top of the tower, the angle of depression to the stake on the ground is 60 degrees. So that's where that belongs. The top of the tower is 80 feet above the ground. So this is 80. How far is the stake from the foot of the tower? So we're trying to figure out this. So my first question to you here would be, are we trying to find a missing angle? No. And the reason we don't, the two ways we know we're not trying to find a missing angle. Number one, if you have either one of these angles in the triangle, the two acute angles, then you know the other one just by doing 90 minus that. So you don't have to do any trig to get that other angle. The other thing is, what they're asking for is a length, not an angle. They're asking me how far. How far is not an angle. Okay, so we're trying to find a missing side. So that means we will not do inverse sine or inverse cosine or inverse tangent. No inverse here. This makes it basically just a regular old, I'm trying to find a missing side of the triangle problem. In other words, what we did before we got to finding missing angles. So let's look at what we got here. Two sides of my angle. One is the hypotenuse. The other is the adjacent. So this is the opposite. So I'm working with the 80, which is the opposite, and the x, which is the adjacent. So which function do I need to use? Which one is opposite and adjacent? Tan. So I'm going to write my equation, tan of my angle, which I know my angle. It's 60 equals opposite over adjacent. Now, when we are finding missing angles, we do inverses. What is it we do when we're finding missing sides here? Starts with a C. Cross multiply. There you go. So x times tan 60 equals 80 times 1. X still isn't by itself. It's being multiplied times something. So to get it by itself, I divide both sides by tan 60. Sorry, I was off the screen there. And that means that x is going to be 80 divided by tan 60, which means it's time to get out my calculator. So 80 divided by, this is regular tan 60. I'm not trying to find a missing angle, so I do not use inverse. Because this is a 60-degree angle, I'm glad it worked out this way so you could see why it does this. 30s, 60s, because of special right triangles, basically. 30s, 60s, 45s. The calculator sometimes does those in exact form. If that happens to you, remember, press the button above enter, and it'll change it to a decimal. So that's 46.18, so about 46.2, whatever it is. Let's look. It was 80 feet above the ground, so it's feet. So I wanted to throw that one in there to remind you that you're not always finding an angle. And if you're not finding the angle, you don't do an inverse. Inverse is something that's only for finding missing angles. And that is it. So I will sign off now. See you later. Okay, so we're sitting in class, and I just asked my students to go ahead and try these 4 problems, and I realized it's not a bad idea to throw them on in this video and let you try them as well. So go ahead and hit pause and take a moment to try these 4 problems, and then you can see the solutions in just a moment. Okay, so I want to go ahead and show you the answer to number 1. Ta-da! And one of the reasons I wanted to stop here and show you that first is I just told my students, and I want to tell you as well if you're watching this video, on the ones where it has all 3 sides, you can set up any equation you want. You could set up a sine equation because you do have the opposite and the hypotenuse. You could set up a cosine equation because you have the adjacent and the hypotenuse. It's up to you. You could set up a tangent equation. You should get the same answer anyway. The work will look a little different if you set it up with sine and I set it up with tangent, but we should both end up with the exact same angle measure. So keep that in mind. On 2, 3, and 4, you can set it up using any one you like. Okay, so here's your work for number 2 and your answer for number 2. I went ahead and wrote what I got as a decimal, but since it asked me to round to the nearest degree, my answer would really be 16 degrees. Okay, if you haven't done 3 and 4, pause now or forever lose your chance. And there's the work and the answers for 3 and 4. All right, hope this helped you and you feel very comfortable now finding missing angles. Remember that the only time we do inverse functions is to find missing angles. If we're not finding a missing angle, we use the regular sine, cosine, or tangent. The other thing to remember here is you did not have to use the same function as me. You could have used cosine or tangent here, or use sine or cosine here, or sine or tangent here. You should still get the same answer I got though. Your work would look a little different, but your answer should be the same.